Welcome back to Part 2 of Module 11, Lesson 2, Reflections. We're going to pick up with resource number 10, which talks about coordinate notation for reflections. Let's watch this video and see what we can learn.
The graph shows triangle ABC with vertices A, 1, 2, B, 2, 4, and C, 4, 1. To determine the coordinate notation for a reflection across the x-axis, examine the points of the preimage and its image. The reflected image has vertices A', 1, negative 2, B', 2, negative 4, and C', 4, negative 1. Notice that the y-coordinates of the image are the opposite of the y-coordinates of the preimage. This is because the preimage and the image are the same distance from the x-axis. So, the coordinate notation for a reflection over the x-axis shows that the y-coordinates are opposites. To determine the coordinate notation for a reflection across the y-axis, examine the points of the preimage and the image. The reflected image has vertices A', negative 1, 2, B', negative 2, 4, and C', negative 4, 1. Notice that the x-coordinates of the image are the opposite of the x-coordinates of the preimage. This is because the preimage and the image are the same distance from the y-axis. So, the coordinate notation for a reflection over the y-axis shows that the x-coordinates are opposites.
Well, that looks pretty simple. In fact, that's just downright easy peasy, isn't it? Let's apply that to example number 3, which is reflect using coordinates. Triangle RST has coordinates R at point 2, 1, S at point negative 1, negative 3, and T at point negative 2, 0. We want to write the coordinate notation for reflection across the x-axis. That means the x values are going to stay the same, while the y values are going to become the opposite of what they are to create the coordinates for a triangle R', S', T', also known as the new image. So first thing we're going to do, write the coordinate notation for the reflection across the x-axis. So when a point is reflected across the x-axis, the x-coordinate remains the same, and the y-coordinate will be the opposite of the y-coordinate in the preimage. Check that. All of that checks. Good. We're making progress here. So if the x-coordinate is staying the same and the y is going to be opposite, R' is going to become 2, space, negative 1. Next, we're going to have S', which is currently negative 1, 3. The negative 1 is going to stay the same, space, and now we're going to have a negative 3. And then for the T', the negative 2 is going to stay the same because that's our x value, space, and 0. Well, guess what? There's no such thing as a negative 0, so 0 is going to stay the same as well. Take that and check it. All that checks. So without drawing anything out, without doing any mathematical operations, we were able to just look at this and determine what the location of those new points were going to be when we reflected it across the y-axis. Yep. Looking across the x-axis. Now it's going to be your turn. Pause the video, work extra example 3 on your own. Go ahead and do that now. Triangle JKL has the coordinates listed here. The triangle is reflected across the y-axis. That means the x-coordinates are going to end up changing. So, write in coordinate notation for the reflection across the y-axis, and then write the coordinates for the triangle J', K', L'. So, what's going to change here? We're going to end up getting a negative x, space, y is going to be the layout of the new problem. Check that. That part checks. That means when we take and plug our values in, we did have a negative 2, negative 3 for J, so that's going to become a positive 2, positive 3, negative 3. So that'll go right there. K was negative 5, negative 2, so now it's going to become a positive 5 comma negative 2 except, and then L was negative 6 negative 7, so that is going to end up becoming a positive 6 comma space negative 7 except. And just by doing that, we found out what the location of each of the new points were going to be without doing anything real hard or complicated. Our final activities wants us to describe the reflections. So the coordinates for triangle EFG and its image are going to be shown. So right here you have your pre-shape, and here you have the new image, okay? Your pre-image and your image. What is different? What changed? The y-coordinate changed. If the y-coordinates are opposites what they were, what axis did it reflect across? It reflected across the x-axis. That's all there is to it. So we're going to take and say compare the coordinates of the pre-image to the coordinates of the image. The x coordinates are going to be the same. The y coordinates are opposites. The reflection can be described with the notation of xy goes to x negative y. So the transformation of triangle xyg is going to be reflected across the x-axis. Check your answers. That's all there is to it. Now it's going to be your turn to do the last extra example 4, where you're going to take and describe the transformation using words. Triangle WXY is reflected across the what? Go ahead and do that now. Alright, looking at this, I see that you have the x-axis became opposite, while the y-axis, or the x values became opposites, while the y values stay the same. That means since the x is the one that's opposite, we're reflecting it across the y-axis. So I'm going to try it as y hyphen AXIS. That's the way it's normally spelled. Check, and it's checked. That's all there is to doing these. That's it for today's lesson. Get started on your homework. Bring any questions you have to me in class tomorrow.